Hey everybody, what's up? Did y'all ever hear that joke about oxygen and potassium going on a date? Well, it went okay. Okay. Did you like that? Well, I'm about to geek out on you even more, so brace yourself. But seriously, how would oxygen and potassium bond? Let's review. Ionic bonding happens when a metal and a nonmetal get together. Potassium is a metal and will form a cation when it loses electrons. Oxygen is a nonmetal and will gain electrons, forming an anion. When these two elements get together, they form an ionic compound called potassium oxide. The chemical formula is K2O, not OK, so maybe the second day will go a little better. Anyway, now you kind of remember how to name compounds and determine chemical formulas. Take a look here. These are Lewis dot structures. All those dots around the element symbol represent valence electrons. These outer electrons, or VEs, participate in bonding and are responsible for an element's chemical and physical properties. The cool thing about Lewis dot structures is that we can use them to help us visualize ionic and covalent bonding. That's good for me because I'm a visual learner. Oh, and I hope you like to draw because we'll be doing a lot of that. Visualizing ionic bonding can be as easy as 1, 2, 3. Here's what happens when potassium and oxygen get together. Let's draw the Lewis structures for each atom. For every one oxygen atom, 2 potassium atoms are needed to form potassium oxide. That's because oxygen has 6 VEs and needs 2 more electrons to be happy. Potassium wants to lose 1 VE because the second outermost energy level has a full octet. Remember, all atoms are wannabes. They want to be just like the noble gases. So, both potassium atoms are ready and willing to lose an electron to oxygen. After you've drawn your Lewis structures, draw some arrows to show the transfer of electrons. Okay, now we're left with 2 cations and 1 anion. The ionic compound is uncharged. There must be just as many positive charges as there are negative charges for this to work. If you want to use the crisscross method first to figure out the chemical formula and then draw the dot structures, that's cool too. Now we need to complete the drawing. Follow these steps. List the cation first, followed by the anion. Draw 8 dots around the anion to show the completed octet. Place brackets around each symbol. Write the charge of each ion outside the brackets. Make sure the charges add up to 0. If the charges don't add up to 0, add the numbers in front of the brackets to represent how many of each ion would be present in the compound. So let's check my drawing. I have the cation, potassium, listed first, followed by the anion, oxygen. I have 8 dots around the anion showing the completed octet. I have brackets around each symbol. I have listed the charges of each ion on the outside of the brackets. And since I placed a 2 in front of the brackets around potassium, my charges add up to 0. Okay, great. Now I can picture the electrons and understand bonding way better. Kinda cool. Okay, let's draw some more. Lewis structures can also be used to help us see what happens when atoms form covalent bonds. Covalent bonding happens between 2 nonmetals and electrons are shared. We can see this using 3 steps called the NAS method. What's the NAS method? Not as simple? Well, that might be true, but actually, NAS stands for need, available, and shared. Carbon and hydrogen can bond covalently in a number of different ways, creating many different organic compounds. Methane is a greenhouse gas and contains 4 hydrogen atoms and 1 carbon atom. Methane's impact on global warming is 23 times as great as carbon dioxide's. What? Why haven't I heard of this, and where is all this methane coming from? What? No way. Turns out that cows emit a massive amount of methane through belching and a smaller amount through flatulence. Some experts say that cows release between 100 and 200 liters of methane a day, an amount that is comparable to the amount of pollution a single car produces in a day. Whoa, that's crazy and kind of gross. Anyway, let's look at methane's covalent bonds. I've heard enough. To draw any Lewis dot structure for a covalent compound, you first got to figure out how many electrons each atom needs to reach a full octet. For most atoms, this is 8, but hydrogen is the only exception. It needs 2 electrons to have a full outer energy level. For the second step, determine how many valence electrons are available by adding up the VEs for each element in the chemical formula. Step 3. Subtract the numbers involved to find out how many electrons are shared. A bond is formed with 2 electrons, so divide by 2 and find the number of bonds to draw between the elements. Okay, let's draw methane using the NAS method. Carbon needs 8 VEs, and each hydrogen atom needs 2 VEs to reach their happy state. So for need, we can write 8 plus 2 plus 2 plus 2 plus 2. That's 16. Looking at the PT, you can see that carbon has 4 VEs and hydrogen only has 1. Remember, the group numbers tell you how many VEs an atom has. So, for the A part of the NAS method, we can add together 4 plus 1 plus 1 plus 1 plus 1. Now, for step 3, subtract the number of VEs available from the number of VEs needed. 16 minus 8 is 8. That means the methane molecule shares 8 electrons among its 5 atoms. 8 divided by 2 is 4. There are 4 bonds between the carbon and the hydrogen atoms. Okay, I hear what you're saying, but I'm still not seeing it. No worries. Just draw what you do know. The Lewis dot structures for each atom. We know that carbon is the central atom for the molecule. Here's what we have so far. Carbon and its 4 VEs surrounded by hydrogen, each hydrogen with 1 VE. A covalent bond forms when 2 electrons are shared. The NAS formula tells us that methane will form 4 bonds between 8 electrons. Oh, okay. I've circled the electrons to show sharing. To polish up our drawing, we can replace those circles with lines. If there are any non-bonding electron pairs, we would draw those in too. Cool, and my drawing's not that shabby. One more quick example and I'll leave you alone. Let's draw carbon monoxide. What's carbon monoxide? It's a gas produced from incomplete combustion, or burning of fuel in cars or furnaces. It is a colorless, odorless, deadly gas. If inhaled, the gas prevents hemoglobin in your blood from absorbing oxygen. If fuel-burning appliances aren't maintained, they can release this toxic gas into someone's home, poisoning them without the person even knowing what's happening. Scary. Luckily, carbon monoxide detectors can be bought to prevent such accidents. The chemical formula for carbon monoxide is CO. Each atom needs 8 electrons, so a total of 16 electrons are needed. Looking at the PT, we can see that carbon has 4 VEs and oxygen has 6, so there are 10 VEs available. Subtract the available electrons from the number needed, and you get 6. This means that carbon monoxide shares 6 electrons through 3 bonds. One thing different about covalent bonding is that atoms can form single, double, or triple bonds. Here is the electron dot structure for carbon and oxygen. Here I've drawn 3 bonds between oxygen and carbon. The 2 atoms are sharing 6 electrons, but the non-bonding electrons have to be drawn in too. We're not done yet. In this drawing, I have replaced the circled electrons with straight lines to represent bonds. Carbon and oxygen each have 2 non-bonding electrons and 6 shared between them. Now, each atom has an octet. See, drawing in chemistry class can be kinda cool, and really useful for visual learners like me. I think that's enough talk about gases for one day. Until next time, I'm out. Bye guys.